Part 6. Multiplying polynomials. The distributive property can be used to perform any polynomial multiplication. Each term of one polynomial must be multiplied by each term of the other polynomial. So really, this section is similar to multiplying two binomials, so FOIL. It's just bigger. Example 1. Using the distributive property to multiply two polynomials. So here, you see that we have a binomial along with a trinomial. Here, let's use blue again. So binomial, trinomial, and we just use distributive law. So we've called those rainbows before because it kind of looks like rainbows. So the first one, 3k times k squared. So 3 has no numbers to go with, or a 1, I guess. K times k squared is k cubed. 3k times minus 2k is minus 6k squared. And 3k times minus 7, the two numbers go together, so that's minus 21. And then the k has there's 1k, that's it. So that's the first 3. Then the next set, so the rainbow is underneath, so plus 4k squared. Let's see, 4 times minus 2 is minus 8k. And 4 times minus 7 is minus 28. So now that we have all of these, there's 6 terms there, but there's going to be some like terms, just like in FOIL. So look, I've got a minus 6k squared and a plus 4k squared. So once we have those numbers, we just add or subtract the coefficients. So look, 3k cubed, he's all by himself. Minus 6k squared plus 4. So minus 6 plus 4 is minus 2k squared. Then the k terms are also alike. So negative 21k minus 8k. So negative 21 minus 8, that's negative 29 k's. And then the minus 28 has no like terms. So that is our final answer. So question B here, again, is same sort of idea, but it's just a little bit bigger. So as you can see, that's a trinomial times a trinomial. So this is going to make 9 terms, but there's going to be a whole bunch in between. So have a look. So this rainbow, rainbow, rainbow. So negative 2t squared times 5t squared. So negative 2 times positive 5 is negative 10. T squared and t squared makes t to the 4th. Negative 2t squared times negative 2t. So negative 2 times negative 2 is positive 4. T squared times t is t cubed. And negative 2t squared times 1 is just negative 2t squared. Anything times 1 is itself, so we're good there. Now let's do the second one. We'll put them underneath. So 4t times 5t squared is plus 20t cubed. 4t times minus 2 is minus 8. T times t is t squared. And then 4t times plus 1 is just plus 4t's. And then the last one, and I'll write in a different color for you guys just so it's a little easier to see. So the last set is that set of rainbows, or that distributive law. So negative 3 times 5t squared is negative 15t squared. Negative 3 times negative 2t is positive 6t's. And negative 3 times positive 1 is negative 3. I should probably change back to blue. Now, see, like I said, it's 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. But there's going to be a whole bunch that are like terms. So t to the 4th, there's only the 1 t to the 4th, so negative 10 t to the 4ths. Let's see, we'll underline the cube. So 4t cubed, 20t cubed. That's it for t cubed. So 20 and 4. Both positive makes positive 24 t cubes. Awesome. Let's see, let's circle the squares. So there's a negative 2t squared, 8t squared. Oh, look, there's a minus 15t squared as well. So one thing about these, they're all negative. So because they're all the same sign, we can just add the numbers and then we just know that it's negative in the end. Okay, so let's see. 2 plus 8 is 10, plus 15 is 25. So that is negative 25t squared. Okay, if you don't like how I did that, just type it into your calculator. It's fine. No one's going to say anything. We don't judge. It's all good. Okay, let's put boxes around the t. So we got 4t and 6t. So that is plus 10 t's and then minus 3. So even though we started out with 9 terms, we end up with 5. So again, we would just call this a polynomial, because remember, anything bigger than a trinomial is just a polynomial. Okay, so that's that one. That's as big as they get. You know, they get a little more complicated, but that's pretty much the idea. Okay. Okay, so example 2. So multiplying polynomials with more than one variable. Okay, and we put this one in with a squared sign, just, okay, well, see if you're paying attention and if you know what the squared sign means. So that's 4k plus 3m. Remember, squared just means times itself, so 4k plus 3m's. Okay, no, not a big deal. Really, the second letter really isn't a problem either, but let's just play with this. This is a FOIL. So there's a binomial times a binomial. So 4k times 4k. So 4 times 4 is 16. K times k is k squared. Now, look at this next one, though. 4 times 3, that doesn't change. It's still plus 12. But you have a k and an m. Now, they're different letters, so really they just tack on. And you could say km or you could say mk. It really doesn't matter. They're the same thing. Okay, order doesn't count for multiplication. Okay, so down here, so this is going to be 3 times 4, so that is plus 12 again. And there's an m and a k. So I'm going to write it this way just to prove a point. mk, and then plus 3 and plus 3 is plus 3 times plus 3 is plus 9, and then m squared. Now, if you look at this, the o and the I combined before, well, they're going to combine now too. The thing is, remember my little analogy from earlier, 5 times 3 is 15, 3 times 5 is also 15? The order doesn't matter. A km is the same as an mk, so those really are like terms. So you get 16k squared plus 24, and then you just pick one, I don't know, km, okay, or mk, doesn't matter, okay, and then plus 9m squared. And you're done, that's it. Yay. Okay, this next one, same kind of thing as the very first example in this part. There's a binomial times a trinomial. You'll end up with 6. We might get some like terms. Okay, maybe not as many as before, but we should get some. Okay, so we just do the triple rainbows here, triple distributive law. 2v times 3v is 6v squared. 2v times 2w is plus 4vw's. Okay, I'm going to write it like that. Okay, and then 2v times minus 7 is minus 14v's. Awesome. Okay, now we have the second set of distributive laws. So negative 5 times 3 is negative 15. Then this is w times v, or vw. Okay, if we go in alphabetical order. Okay, so then negative 5. W times 2w is negative 10w squared. Okay, and then negative 5w times negative 7 is plus 35w's. Okay, so we check to see who our like terms might be, and oh, there's only the one set. We have plus 4vw's and minus 15vw's, and the order for the rest of these really doesn't matter. So let's just go in the order that they're already in. So 6v squared, okay, plus 4 and minus 15 makes negative 11 vw's, okay, minus 14 v's, minus 10w squared, plus 35 w's. So there you have the answer for that one. Bum, bum, bum. Okay, often with polynomials, we have to combine operations to get our final answer. Remember that order of operations comes into play here, so BEDMAS. Okay, typically in these cases, we are working with multiplying, adding, and subtracting. All multiplication must be done before any adding and subtracting can take place. Also remember that like terms are terms that have exactly the same variable or variables. Order is not important. So 3xy and negative 8yx, they are considered like terms. Okay, so if we have a look at example 3, simplifying sum and differences of polynomial products. So if you have a quick look here, this guy's a FOIL, and then this guy has a whole bunch of things multiplied together. Okay, so we have to do all the multiplying before we can do any adding or subtracting. Okay, that includes combining of like terms. So, well, I guess we should look inside the brackets because technically that's first. But if you look, 4m plus 1, they're not like terms. 3m minus 2, they're not like terms. 2m minus 1, nope. 3m plus 4, okay, nope, there's no like terms inside the brackets. So we do brackets, there's no exponents here, there's no division, so we're already down to multiplying. Okay, so multiplying binomials is just FOIL, or distributive law. So 4m times 3m is 12m squared. Okay, 4m times minus 2 is minus 8m. 1 times 3m is just plus 3m. And 1 times minus 2 is minus 2. Okay, so that is the first chunk. Okay, now look, I'm going to put this plus sign, I'm going to make that big, because that's that plus sign there. Okay, and now from here, what I'm going to do, everyone, is this 2 can distribute into both of those. So let's just get rid of that right off the bat. So that's going to be 4m minus 2, and then times minus 3m plus 4. Okay, so we'll do that, and then we'll simplify the second set of binomials. Okay, so we'll just distributive law those. So again, we're going to have all this 12m squared. Now look, we might as well combine these as well. Negative 8 and plus 3 makes negative 5m's minus 2. Okay, again, I'm going to make that plus sign really big. So 4m times minus 3 is negative 12m squared. 4m times 4 is plus 16m's. Negative 2 times negative 3 is positive 6m's. And negative 2 and positive 4 makes minus 8. Now, technically, very technically, those things, the square brackets, those are the parts separated by the plus sign. Now, a plus sign really doesn't change anything because plus and negative is still a negative. Okay, plus a positive, we're still adding. Okay, so not a big deal. So let's just do some simplifying. 12m squared minus 5m minus 2 plus negative 12m squared plus 22m minus 8. Now, because we're adding, we really don't need those brackets, but we could have them anyways. It does matter when you're subtracting, because the negative sign would distribute to everything. The plus sign is just plus 1, so plus 1 times everything is just itself, so it really doesn't change. So look at this. Let's do these squareds first. So 12m squared plus negative 12m squared. So plus and negative is just negative, so 12m squared minus 12m squared. Okay, so that is 0m squareds. They just cancel. So there's no m squareds here. Okay, cancel, cancel, bye-bye. Okay, and then negative 5m plus 22m's. Okay, so negative 5 plus 22 is 17m's. And negative 2 plus negative 8, well, of course, that's just minus 10. So there is our final answer. Awesome. Okay, B in this case, again, it's kind of big, but that's all right. So we're going to have a trinomial times a binomial. And then, oh, look, I put a minus sign on this one. So just to prove that point, the minus one, that is going to matter. We're going to keep that second bit in brackets then. Okay, and remember a squared, okay, let's just get rid of that squared, and we know that squared is times itself, so plus 3k. Awesome. All right, so let's just distributive law here. Okay, so 6h times 2h is 12h squared. Okay, 6h times minus 3 is minus 18h. Okay, so then we got k times 2h, so that is plus 2h 2hk, and k times minus 3 is minus 3k. Okay, and then the last one, so minus 2 times 2h is minus 4h, minus 2 times minus 3 is plus 6. So this, everyone, that's the first chunk. Here's the big minus sign that represents the minus sign in between the two. Okay, we're also going to leave this guy in brackets. So 4h times 4h is 16h squared. 4h times 3k is plus 12hk. Awesome. Okay, 3k times 4h is another 12hk. And 3k times 3k is plus 9k squared. Okay, I guess we had the big square bracket. So, all right, now there's going to be like terms that we can combine here. Let's see. So we've got a 18h and a 4h. So those go together. So we have 12h squared minus 22h's. Okay, we have a plus 2hk minus 3k. Okay, and then plus 6. That's all the simplifying we can do there. Subtract, so 16h squared plus 24hk plus 9k squared. That's all the simplifying we can do there. Now, this is why we kept the second term in brackets. That negative, that's really going to distribute to all those chunks, which is going to make them all negative. So really, this is minus 16h squared minus 24hk and minus 9k squared. Okay, we're going to subtract all of those things. Okay, so anyways, we got 12h squared minus 22h plus 2hk minus 3k plus 6. Okay, so let's see what we've got here. We've got an h squared and an h squared. So negative 12h squared minus 16h squared is negative 4h squared. Okay, so those ones are done. You have a negative 22h. Okay, there's no single h terms over here, so it's just minus 22h. Okay, plus 2hk. Ooh, minus 24hk's. So that's going to be minus 22hk's. Great. Then you have a minus 3k, no single k's, so that's just how he's going to end up. Okay, we have a plus 6. Okay, nothing over there. And we have this minus 9k squared. Now, usually, everyone, we put the constant term last. So if I go plus 6, that's probably best. But really, on big questions like this, I'm not going to mark order. It's not that big a deal. But this is our final answer. And yes, it is big. I get it. But you don't have very many of these, but you do need to know how to do them. Okay, and one last example for this. All right, example 4, extra layer of think. Determine the area of the shaded region. Write your answer in the simplest form. Okay, so really all this is about, if I did not have this little box in here, if that shading just kept going, the area of the big rectangle would be 7x minus 2 times 3x plus 5. Okay, perfect. Well, the thing is, though, the little rectangle is there. So hopefully you guys can see that if I take the area of the big rectangle and subtract the area of the little rectangle, okay, I will get the area that's shaded. So area of the little rectangle, it looks more like a square, sorry, but whatever. Okay, so 2x times 3x plus 1. So if I take the big area, subtract the little area, then we get the total area of the shaded part. Okay, so let's do that. So 7x times 3x is 21x squared. 7x times 5 is plus 35x. Negative 2 times 3x is minus 6x. And negative 2 times positive 5 is negative 10. Okay, so simplifying this, 21x squared plus 29x minus 10, right? 35 minus 6 is plus 29. Awesome. Okay, the area of the small one, so that is 6x squared plus 2x. So we're going to go the area total, or I guess shaded, equals the area of the big rectangle minus the area of the small rectangle. So 21x squared plus 29x minus 10 minus 6x squared plus 2x. Okay, now instead of distributing that negative like I did last time, let's just subtract them one at a time and see what happens. So 21x squared minus 6x squared. So 21 minus 6, that's 15x squared. Okay, then you have 29 x's minus 2 x's. So 29 minus 2 makes plus 27x. And then negative 10 minus, okay, and there's no constant term in the second one, so it's just minus 10. So there is your final answer. Awesome. So we are done this part. I want you to practice this material by completing these questions. So that's section 3.7 in your textbook. Starts on page 186. So try these all. When you're done, show your teacher. Go ahead and check your work in the back of the textbook. That's what the answers are there for. Okay, just to make sure you're on the right track. But if you have questions, give them a shout. Your teachers will be able to help you. And good luck. Finish those up, and we'll see you next part. Thanks.